Another instance of making sure that you're caching as much as you can. So whenever you think of a post, an HTTP post, typically you assume that it probably cannot be cached. There are a couple of reasons why a web application uses posts. Right? One is because it's asking the user to submit something to the server. Right? So it could be credit card information, user login password, or whatever. And in those cases, for sure, it's not cacheable. You don't want to cache user identifiable information in any shared cache. However, a lot of times a post is used for other reasons. It's used to get past the limitations of an HTTP GET. So think about a search scenario. You could pass the search parameters in the query string of a GET request. But what if you had a very complex search request where you had a lot of parameters and you wanted to submit a lot of name-value pairs? You might hit the restriction of the URL length. In those cases, you could implement it in a post where those name-value pairs are in the body of the request. Now, in this case, it's a search, and it's not personalized, let's say. We should be able to cache it at all the tiers, right? The reverse proxy, CDN, even browser. But we don't have anything in the URL now to uniquely identify that particular object. And one way to get past it is to generate that unique identifier. Right? So you could take a hash of the post body and tag it to the URL string, and that could represent your cache key. So HTTP response, post responses can definitely be cached, but it requires some sort of tweaking and optimization and setup, especially at the CDN and proxy to be able to cache it. Another optimization, again, referring back to an article that Steve wrote, and he really described it way better than we could explain it. So I would encourage you to read this article called Pre-Browsing, and where Steve talks about more than these two optimizations, but we'll focus on these two. So prefetch and prefresh. Prefetch is essentially telling the client to fetch and cache a resource in advance of the client needing that resource to render that page. Right? That's what prefetch means. So an example could be a browser prefetching a JavaScript file before it needs to execute it later down. Or it could even mean prefetching an entire new page in anticipation of the client clicking on that link in the page. It could also mean something more interesting. Let's say your CDN, if it can parse HTML. So if it's a newer CDN, it should be able to do that. And it can actually parse the HTML and pre-request all the embedded objects in advance of the user requesting for it. So think about it in the scenario of this is the very first time that end user has hit that particular edge server. And the edge server's cache is cold. In that case, what you're telling the edge server to do is essentially pre-warm the cache before the end user has a chance to request for those objects. Because it is going to request the objects because it asks for the referring HTML. Prefresh is a way to revalidate content, but not let the client wait for that revalidation to happen. So going back to the scenario we talked about where when a cache entry expires, the client will typically block that request and go forward to the server to revalidate it. So think about occasions when there might be a network latency or there might be disruptions. Even that lightweight revalidation can take a long time. And so one way to optimize on that is to use something called a prefresh, where you're telling the client that go ahead and serve what you have in cache, but in the background refresh it. So the next time you need it, or if it's a shared cache, if the next time another user needs it, you have the fresh copy in your client, in your cache. There are some HTTP headers which allow you to do this at the browser. They are not well implemented across the board, And so you have to use it with caution. But at the CDN, you can definitely, because it's more of a controlled environment, you can use this technique, and we do it all the time. Another example of an instance which might make a page or a dynamic resource or even a static resource uncacheable is if it's behind some sort of an authentication authorization. So think about, let's say, a financial services company that provides documents in the form of PDF downloads only to registered end users. In those scenarios, it will show the link to the end user, but it will allow the end user to download it only if it thinks that the end user has the privileges for that particular document. So the document per se is static, right? It doesn't change from one user to the other. But the fact that it needs authorization makes it uncacheable on the face of it. So what can you do? There are many techniques to be able to cache the page. You could set a token that can be validated at the CDN cache. In this scenario, what we're doing is we are segregating the control flow with the content flow. Right? So we're segregating the authorization request flow from the content serving request flow. So the first time, so let's say a user requests for an object that's already in cache. In this case, the CDN edge, instead of serving the resource back immediately, will pause and make a blocking request to an authorization server. It will send all the credentials from the end user's request, let's say any cookies or any other headers, which identifies that user all the way to the authentication server or authorization server. The authorization server will receive this lightweight head request. So a head request is a lightweight request in that you're just asking the server to send you the headers back. You don't want the body. So you're allowing the server to send you a yes or a no, right? And if it's a yes, then the edge will serve the object from cache. If it's a no, the edge can serve an error response. If there's a revalidation attempt at the edge, so let's say the cache is expired, or if it's a core cache, then it can go and fetch that object from the content cloud, which can be the same as the authorization server, or it could be different. So we're using CDN liberally, but think of it as any proxy that you can control. Any optimization that you can implement on a CDN, you can implement on a reverse proxy that you put in front of your origin infrastructure. Or you could build out your own CDN, right? One thing to be careful of is you want to absolutely set a must revalidate in this scenario. So you don't want to serve an object from cache if you cannot connect back with the server. You want the chance to be able to authorize the end user. Yeah.
If you're caching at your CDN, is the value of having a proxy in service limited?
Value of having a proxy, as in a proxy at the origin? I mean, the origin proxy is doing something different, which is it's shielding your application infrastructure from generating responses. So you want your application servers and that infrastructure to focus on the high CPU request responses, like generating a search response, for example, et cetera. So you don't want to tax that server cluster with serving static content. So a reverse proxy allows you to offload that even at the origin. So yes, a lot of our customers do not have a reverse proxy, and it is an additional cost to set up. And so there is a trade-off there. Any other questions? Yeah.
Refresh.
Yeah.
Do you have a best practice for balancing request to origin versus getting that performance gain? And is there like content that is more suitable, like large file downloads versus?
So you should think about it in the sense of how long are you okay with serving stale content, right? So typically on our network we set a prefresh, a background prefresh, which is 90% of the actual time to live. So let's say the time to live is 10 minutes. any request that comes in between 9 and 10 minutes, we will do a background refresh, right? So it really depends on how long you're okay with serving an object potentially stale. You could use it for any static resource. And by default, we use it for every static resource. Any other questions? I should have paused for questions more frequently, yes.
In terms of pre-freshing, is there a risk if you start it passively, you've got an end user base which is hugely global, you're on a lot of different edge servers, a lot of different edge servers will warm the majority of your content, but there are some items you don't currently cache. You want to cache them, but you want to cache them with quite a low TTL to understand the impact of it before pushing that up. But you also want to pre-fresh. Is there a risk that you'll introduce more traffic back to origin by doing that?
You're not introducing more traffic. You are introducing a little more traffic because in this scenario, we're going back every 9 minutes instead of every 10 minutes.
Yeah, the traffic's going to be commensurate with the load that's actually coming into the site. So you're not going to introduce a significant amount of additional traffic to the origin.
Yeah, I'm trying to understand if there's any native way in AppMine specifically of understanding how to set your pre-freshing correctly for a piece of content like that. Because if the piece of content is currently not cached, that's fine. You know how much origin load you're creating with that content.
Yeah.
Right? But if you start to cache it with a low TTL, pre-fresh it, you create yourself a problem if you don't fully understand the hit rates on each origin.
Yeah.
Say
Right.
it averagely hits it lives in every 10 minutes. And you have a TTL of 5 minutes and you're pre-freshing.
Right.
I think what you can do is take the worst case scenario and treat the pre-fresh TTL as your actual TTL. So if you do that, then you're anticipating the worst case scenario, which means that every cache is very hot and getting tons of requests. So the pre-fresh is triggering every single time. In most cases, the pre-fresh may not trigger. So by assuming that to be the actual TTL, you factor in the worst case scenario. Any other questions? Cool.
So dynamic pages, and we're going to have a section on caching dynamic pages as well. But you can think of dynamic content as just any type of, like a HTML asset is just like any other web resource. To a web server that's serving it up, it can't really distinguish it between anything else it's serving. To us, or to the application developers as well, it can potentially contain a lot more personalized information, and sometimes the server-side backend processes that are generating that content can be a bit more expensive from a performance perspective. So this content is very very sensitive in terms of how long it takes to load. So caching it could produce a significant win in terms of scalability and performance. But there's certainly risks to caching dynamic content. So in this particular example here, you can see that we have this is our demo app, our demo application. So it's a Madison Island Magento theme. But you can see that this is the homepage for it, and it's essentially a cacheable resource. But what happens when you log in? You wind up seeing, in this case, welcome Rakesh. And then if that welcome Rakesh message is inside of the HTML, then that HTML is essentially personalized. So there's a number of techniques there's a number of techniques that you can use to manage when you cache it, how you cache it, and when you don't serve something from cache. And we're gonna talk about that some more in the next section as well. Another concept that it's not technically caching, but it's similar, is dealing with redirects. So a redirect, if you think of what happens when you're issuing a redirect, you're making an end user is making an HTTP request. Let's say example.com/. That request goes through the CDN. It goes forward to your origin, and then your origin returns that let's say 302 redirect to index.html. So you actually don't have any. Your user's not actually seeing anything until he makes that request for /index.html, gets a response, and starts rendering something to the page. So you can think of a redirect as head-of-line blocking because you're not actually seeing anything until that redirect tells you where to go. serving a redirect from a CDN is going to not only offload the time it takes to generate that redirect from your origin, but also reduces the round trip latency between the content delivery network and your origin. So there's both a performance gain for that as well as a capacity gain. Now in this particular example here, you can see that there's a desktop and a mobile device, and there's a desktop and a mobile origin server. You can also do some logic. So you can build some custom logic into a redirect, especially when you're doing it at the edge. So in this case, you can see the desktop browser goes to the content delivery network, who's essentially acting as a traffic cop, and says, "Oh, you've requested www.example.com. Go forward to the desktop origin server." And for www.example.com, for a mobile device, we've detected you're a mobile device. We're going to send you a redirect to the m.example.com site. And at that point, the mobile device would get the location for that and send the request. So this is so essentially implementing these at the edge it speeds up the time it takes to get those to get your user to the right place. Go back one slide. One thing to be aware of is you should use appropriate status codes when you do the redirect. So you can configure 301 or 302. 301 is a permanent redirect, or 302 is a temporary redirect. There's some SEO benefits for that as well, in terms of if you do have a 301 redirect, then the pages would be grouped together from an SEO perspective. So you want to make sure you configure a permanent redirect as a permanent redirect when you implement those. Here's an example of a really bad mobile redirect. So I blacked out the site because I don't want to embarrass anyone. But so mobile device connects to www.whatever.com, and you can see that it took a long time to start downloading some resources from the www domain, and then eventually it redirected to the m. domain. So what's actually happening here is this particular website had a JavaScript package that identified that the user was using a specific mobile device. Based on the user agent, and then issued a window.location redirect that sent the user to www. So what you can see over here is that the client loaded like 25 objects. It was actually about 1.5 MB of content before it redirected to the mobile site, and the mobile user didn't see anything for like 11 seconds. So this is the worst way to do it.
Is the redirect a normal use case for CDN? Is that something you see a lot of people using it for, or just it's not? I'm not going to say edge, but it's more of an edge case versus a true CDN.
We do see a lot of requests to implement redirects, both just implementing redirects at the content delivery network, as well as implementing custom logic. So, for example, geographic redirects to redirect a user to a geographic subdomain or a different path or set a cookie. So implementing logic at the edge closer to the user prevents that round trip. We also see in a lot of cases where implementing a massive number of redirects, let's say a site's replatforming, and all of their URLs are going to change. They may want to have a couple of thousand redirects configured that they would otherwise do within Apache. So like having like mod redirect or rewrites, they would have the content delivery network do that for them. So we basically do all of those redirects at the edge. You don't have to manage any of that at the origin, and it's faster for the end users. Any other questions? Okay.
So we talked about the browser cache. So every browser has a cache that is unique to that particular end user, but it's shared across all the sites that user can go to. And there have been a lot of studies, and people have done a lot of diagnostics to notice that it's very unreliable in terms of what are the chances that the user is going to hit something in the cache. It's very unpredictable. You're at the mercy of the user, maybe deleting the cache proactively, or you're at the mercy of the implementation of the cache by the operating system or the browser. A lot of times, within a few days, the entire cache is refreshed or changed altogether. So there are some, historically there have been problems in terms of relying on the browser for deterministically caching and pulling items from cache. That has changed recently with HTML5, and it has the concept of local storage, which really allows you to programmatically store objects in cache and put, delete, and remove operations. It still is limited, right? So most browsers will impose a 5 MB limit. So you can do some interesting FEO type optimizations using the local storage. For example, you can decouple the download versus the execution of a JavaScript file. And we won't go into these techniques because it's slightly out of scope. But needless to say, it's still limited to some specific use cases. Because of its size, you can still not programmatically store images, for example. That will change. So at this session or at this conference, there are some sessions around service workers. And service workers allow you to actually implement almost a proxy at the client and control it in a very fine-grained manner. So I encourage you to attend those sessions. That's a developing technology, so it will take some time for it to go mainstream. For now, for this talk, we're going to limit ourselves to making sure that the native browser cache is as optimal as possible. So next, we're going to talk about invalidation and purging. I want to pause and just ask you guys, there any questions so far? So we went through some caching as a concept. We went through some basics about caching. We went through some advanced techniques. We're going to apply most of those techniques in the second half, where we'll actually show you how we implemented them in a real-world scenario. But any questions before we go into invalidation and purge? Yeah.
You mentioned various things of putting logic at the edge. Is there a standard for that, or if you use Akamai, you have to write it this way, and you use somebody else, you write it that way?
Yeah, unfortunately.
Is there a secret sauce that you have to?
Well, I don't think it's necessarily a secret sauce, but every cache proxy has their own syntax, and so it's there's different capabilities of different CDNs. Some of the all of the techniques we've been talking about, you can do with Akamai. You can also do them with a number of other CDNs as well, and you can do them with open source proxies like Varnish and Squid.
So the only thing that's standards based are the HTTP headers. So any directives that you send down in the response or that comes up in the client, a CDN will implement and honor it, right? So that's the only thing that you can treat as standard.
So
otherwise it's proprietary.
If you decide to go to a different.
Unfortunately, it is a migration cost. Yes.
Yeah.
Yep. Back there.
When I first started working with CDN, my natural inclination was to sort out the business logic at the origin side, to serve the appropriate caching headers, and then just trust those at the CDN side. But it seems like that's not really the right way to go in most cases. You need to split the logic to get the best out of the CDN, and that's what introduces your migration cost.
Yes.
Yeah.
Because your origin can't fully
Yeah.
inform the CDN
Yeah.
what it should do versus the browser.
Yeah.
Your origin should be browser aware, and your CDN should be overriding TTLs.
I mean, you're hitting on a point of the HTTP directives are very old, right? They're spec'd out many years ago, decades ago, and so they don't really allow you to do the kinds of optimizations, even the ones that we talked about here. For example, let's say tweaking. Let's take the scenario. I'm trying to think of it. So let's say you want to vary by user agent. Now, if you do it by the vary header, you're going to cause massive cache pollution at the edge. There are tens of thousands of potential user agent strings. So you really want to implement a special logic that caches based on device categories and not by the actual device user agents. Mm-hmm. So whether it's a mobile or a tablet or Android or iOS. So in those scenarios, you have to then implement on a CDN specific level. And it is, yes, you're introducing some trade-offs in terms of migration costs, but then that's a business decision. Mm-hmm. But we see a lot of our customers implement this all the time. So clearly there's a benefit that outweighs that migration cost.
Static stuff though, you'd still set your own static details rather than just cache control.
Yeah, a lot of our customers rely on cache control.
We can honor the cache control and expires headers that an origin server sets, and then just honor those at the CDN level, and then pass those downstream to the client, or we can override those. It really comes down to the customer's preference.
Yeah, that's what I'm trying to get down to is what most people are doing in that circumstance. Because my inclination was to sort of business logic out, and it is if you ever want to use CDN, at least for your static stuff, or at least if you're testing without a CDN, your origin is actually using the business logic environment for actually how to cache.
Now, if you want to minimize migration costs, the other thing you can do is configure it both. So you can configure everything that you want to do at the origin, but then also configure it at the CDN, because you'll get the performance boost by moving it closer to the end user. So at that point, now you've minimized your migration costs, but you've also maximized the performance for the users, which is what really matters the most in terms of performance.
Well, we're going to be at the break and even throughout the conference. So if you want, we can chat more about it. There was a hand here in front.
Are set cookie response headers also cached?
Set cookie, it depends on what TTLs that you've provided in the cache directive. So cache control expires. At the CDN, you have a lot of flexibility. You can ask it to override or to ignore the set cookie, and a CDN will strip it out before caching it. So that that's a good question.
So the cookie is set in the browser, and that's I'm not sure if it.
Will it cache the?
Well, it sets the cookie when it hits the browser, but I don't know if it. Well, the cookie so the cookie has an expiration. Well, if it's either a session cookie or it has an expiration,
so
that's how long the cookie would be valid for.
It'll depend on when it revalidates. So if it revalidates and gets another cookie, then it's going to.
But then, in terms of whether or not the cookie is cached, let's say on the CDN level, that really depends on the CDN. So the safest way to do it is if you're caching something where a cookie is set, and it's, let's say, a personalized. There's a risk of personalized cookies being cached, and you never want to cache PII. So in that case, you would strip out that cookie, and that's the way, I believe that's the way most CDNs, I know Akamai does it by default. Like if you wanted to cache the cookie, you could, but that would be an override that you carefully consider before you implement.
Yes,
The cookie is not part of the cache key.
Right.
Unless you put it in logic.
Right.
Now you can extract something from a cookie and add that to a cache key. But if you added every cookie to the cache key, you'd basically get a cache pollution.
Back there, yeah.
Yep.
In order to minimize the migration conflict between CDNs, I actually like to have as little conflict as possible in the CDN level. And for this, the very header is actually pretty useful. Does Akamai support the very header?
Yeah.
It's by default, it will not, because of the instances that we've seen where customers shoot themselves in the foot. Yeah. So by default, we'll ignore it unless it's a very specific use case. But you can override anything in the actual CDN configuration.
We also are controlling our origin, so we can just use the very header to.
Yeah. So if you know what you're doing, then absolutely you can configure the CDN to honor it, knowing that you will treat it appropriately. Right. So that can be done for sure. You want to factor in the downstream proxies though. So the gateway proxies, we've seen times when it is not configured or it's not, it is buggy. So you may want to set a downstream private header so that you're caching it at the CDN, at the browser, but not in the in-between gateway proxies, which you have no control over. No, between CDN and the end user, there might be gateway proxies like the mobile network or whatever. Yeah.
Yep. Any other questions?
Yeah. So, for example, talking with the body header, a customer in the origin set the body header for user agent and wants to use it in the cache system. So I guess we'll create a lot of cache objects in the cache. So do you have like a limit, or how many alternates can you create? Or you just, for example, there's a lot of user agents. So how's the logic there work?
It would just cache it for every user agent, which would mean that you would get very low cache.
The ratio will be really low.
Right, exactly. Now if you wind up doing a vary by user agent, there's usually some reason for doing it. So that's where the logic that you're looking to accomplish is something that can be considered, and then you can decide, I want to, I'm trying to identify mobile user versus a tablet user versus a desktop, and then build some logic in at the CDN layer.
Will cache control private excluded from the CDN?
Cache control private,
Depends
you
on the
can
CDN.
tell the CDN what to do.
Yeah.
What's the default?
Default at Akamai is we ignore it.
Yeah.
So you would cache the content?
Yeah. If you configure it to be cache, so by default everything is not cacheable, and then if you choose to cache it, then you're caching it.
Or even private?
Yeah.
The reason is that we go through these settings with the customers, and the private a lot of times is intended for those proxies that you can't control, and you do want to cache those objects at the edge or at the CDN. So it's really it's a decision that gets made when during the onboarding process. Any questions on this side of the house? Any more questions? I forgot that we're supposed to repeat the questions.
Oh, right. Sorry.
For the sake of the video. All right. Invalidation and purge. So this is a very important topic, and it's really whenever you think about a caching strategy, you need to think about what controls you have to invalidate that object. So you could leave it up to the cache directives, the max age TTLs, but there are times when you need to take some proactive action. So we go with the premise that the fastest request is the one you don't have to make, right? So going back to the 3 guiding principles of caching, you want to be able to cache as long as possible and as much as possible. So you want to avoid any cache misses as long as your business is okay with, right? There are 3 options for updating a cache. The first option is the best option by default, right? So relying on a time to live is really the most graceful way to populate a CDN cache and to revalidate it on an ongoing basis. And what I mean by that is, think about the example where you had a 10-minute TTL for your resource. Let's say you have 100 edge servers at the TTL. Those 100 edge servers are going to expire that TTL at any moment between 0 and 10 minutes, right? Depending on when they first requested the object. And in that scenario, the refresh or the revalidate for all those 100 edge servers is going to be spread across those 10-minute interval. And that's what you really want, ideally. You don't want to create a spike at the origin if you don't have to. So it's really the safest way for in terms of protecting the origin infrastructure and still allowing for your business rules to be executed. Mm-hmm. The next level down from that is invalidate, where you're telling the cache to proactively go ahead and tag that content as expired. So don't remove it from the cache, right? But mark it as expired. So the next time you need it, you need to revalidate it back with the server. And the third is really the blunt force method of purging. You're telling the cache to explicitly remove that object from the cache. So remove any trace of that object. So treat it as cold. The next time you get a request, treat it like you never had that object in cache. And that's really the most the riskiest in terms of the origin infrastructure. Going back to the example of 100 edge caches, let's say you purge all the 100 edge caches at the same time, and it's for a content that's really popular, you're going to get 100 requests to fetch that object from the origin at the same instant in time. And you want to avoid that, right? So there are good scenarios where you might want to do it. Let's say for compliance reasons, you let something cache at the edge or at the proxy, which was, let's say, illegal or it's causing any compliance issues, you do want to remove it from the cache. But that happens rarely. So our advice is to use it in the progression of rely on the TTL, if not, use invalidate, if not, use purge. And we'll go through each of these scenarios. So the first one is relying on TTL. We split it in two subsequent requests. So the first time a client requests an edge server, the edge server is cold, right? So it goes back to the origin, fetches the object along with the cache directives, and stores it. And then it sends it back down to the client. Let's say the object has expired on both the browser and the edge. In that case, it's going to do a conditional get to the origin. And that's really the another advantage of relying on the TTL. A conditional get, if you remember, is a get using an if modified since or an if none match added to that request. What it's telling the server is to serve the object only if it has changed. And that's very useful because if it hasn't changed, it's a very lightweight response back down to the edge and back down to the browser. Invalidating is the next one. So in this case, you're not allowing or you're not waiting for the CDN cache to expire gracefully based on the time to live. You're instructing it to mark that object as expired proactively. And what happens is the next time the CDN gets a request from the end user, it is going to block it and send a conditional get back to the origin. So you do get the benefit of the conditional get in this scenario. So if the object has changed, which is the case in this graph, the origin will send down a 200. If it hasn't changed, the same invalidate scenario, but the object hasn't changed, the origin sends back a 304 or a not modified. So the invalidate it's not as graceful as relying on TTLs, but it has some of those benefits of using a lightweight response for majority of the scenarios. Purge, as we mentioned, is a blunt force method, right? So you want to use it carefully. So in this case, the origin or the server is instructing the downstream cache to remove the object from the cache. So it doesn't matter whether it had it or not, or whether it was fresh or not. It's going to issue a full GET request and get a full response. This can be a lot of times suboptimal because a lot of times we see customers issuing a purge, a wholesale purge for the entire website, right? And not for objects that truly have changed at the origin. And in that case, you're starting from a cold cache absolutely at the CDN. So use it with care.
Here's an example from a real customer where you can see here the top line, the black line along the top is the offload percentage. So in this case, this particular customer was offloading 85% of their traffic. In the stacked area graph here, you can see the purple area is the purple area is the cool, go ahead. So the purple area here is the number of 200 status codes, and then the blue area that you can see that's inversely proportional to the offload drops is 3xx status codes. So some of that could be 302 redirects, 301 redirects, and some of it could be 304 HTTP not modified. So what we're seeing here is this particular customer was doing a cache invalidate every morning at 6 a.m. And you can see the drop in offload that quickly recovered. But you can also see the spikes in the HTTP 3xx requests. So this is a purge. We'd see this all 200s. But unfortunately, it was an invalidate, so it's just 3xx. If we take a look on the day before Thanksgiving, you can see that they did a purge. They didn't invalidate in the middle of the day. So you see the offload drop, and you see the spike in traffic hit above just around here. And unfortunately, again, this was HTTP 304s because they actually had a request rate almost as high as Black Friday. So it is definitely dangerous to do massive purges across all of your content during high traffic periods, and it's something to consider as you're building out a caching strategy and configuring automatic purges or invalidates. Any questions on this? Sure.
Do CDNs have the concept of, maybe this is just something you have to do with the origin, is to reduce the TTL? So like you do with DNS, you're going to make a change, you cut your TTL down to 10 minutes versus a day. If you know that a change is upcoming to a particular object, can you essentially, is that what you would use an invalidate for? Or?
In terms of reducing the TTL for something that's already been cached?
Right. Essentially saying that you don't want it to revalidate all the time, but you want it to get the new object within 10 minutes or something.
Right. I don't have any to do that.
So you're asking about, let's say you have a release window, and you know that within that 10 minutes you're going to update a bunch of objects. What happens by default at a CDN or any cache is the object is cached with the time to live that it was told at the time of caching, right? So let's say the TTL was set to 7 days, and your release window happened at the 3rd day. The cache still thinks that it's valid. It doesn't know that at that particular time it needs to check again, unless you do some custom logic or you send an invalidate.
Okay, so that's one of the use cases for invalidate.
Right. Yep. And again, invalidate only things that you know have changed, because even though it's less costly than a purge, a 3 or 4 still means there is a connection overhead to the origin. So even though there is a reduction in the content download, there is the same number of connections being made as a purge. So yes, but that's absolutely one scenario. And this scenario is representing that. It's a slightly bad version of that because they're invalidating everything. And you want to invalidate only things that you know have changed.
Yeah. Any other questions?
So it feels like the entire caching strategy is becoming a lot more complicated going forward, right, with your application team. So typically, would you recommend having a separate team that manages? So we have like 50 applications, right? Would you recommend having a separate team that manages all this caching, or do you have the app team who's responsible for the application learn about all this?
I mean, customers do hire performance engineers, but I think I would leave it to customers or to content providers in the audience. Are there people here who hire specifically just to optimize CDNs or just optimize performance that's separate from the application team? Anybody wants to share?
Yeah, I mean, from SoundCloud, so we, from the traffic team, support the other teams with this knowledge. But ideally, like all the cache logic should live in client libraries, in my opinion. So that every application team needs to worry about it, and it's just there by default. That's my opinion.
Yeah, what we've seen is even though you may not have dedicated performance engineers, a lot of content providers do invest in setting up a framework. So they invest in setting up a framework for what is your performance budget. What are some of the optimizations that any application developer or team in the company needs to follow. And I think that's important, and that's the bare minimum you should be doing if you cannot invest in a full-time performance engineer.
I am the performance engineer. The thing is, with a large company, I work with Liberty Mutual, and you have a lot of internal applications. And we've been looked at it from Akamai and Fastly. You don't have an internal-facing CDN. So we have to create our own CDN internally, and using, for example, Apache Traffic Server, create all the nodes and everything. That becomes a large enterprise undertaking on its own. So that's really the case for companies that have to invest internally and create their own CDNs.
Right.
Right.
So this is the last one.
Right. So in terms of the caching strategy or invalidation recommendations, so if we take a look at this in terms of good, better, and best, so a good strategy would be to execute invalidations at purges at non-peak times, to use APIs to only invalidate or purge what's changed, and so forth. A better would be to use TTLs that are appropriate based on the publishing needs. So you also want to allow the content to be served stale. So for example, if you're unable to revalidate with the origin, then you can still serve that content stale so that the user gets something instead of nothing. And then the CDN TTL should be greater than the browser TTL because you have more control over the CDN than the browser. And the best would be really to version your assets and use very large TTLs because then you don't have to worry about any of this. When you make a change to your content, you can, if you're caching dynamic content, you can purge the dynamic content, and then you basically have you basically have all the other objects rewritten to different URLs. Mm-hmm. You have a question?
Regarding caching this HTML, do you see the best design pattern now as being to allow the origin to invalidate the edge when pages are updated? Because with TTLs for static objects, it's quite easy, and if you're developing working properly, version assets is quite easy.
Mm-hmm.
But actually, if you're operating a CMS or any kind of system like that,
Mm-hmm.
I see it as kind of a poor workflow to rely on TTLs for base HTML.
Mm-hmm.
Because you've got to set it low enough then that there isn't kicking the screen when the content updates.
Right.
So do you see that design pattern quite often where the CCU APIs fall from directly within the application?
We do have customers that basically integrate the APIs with their publishing systems so that they can purge that content. And again, purging it for just what you've changed is a much more effective strategy than purging it for everything.
So we're right at the break, and just to let you know what we're going to cover after the break is, as we mentioned a few times, we've set up a Magento application on EC2. We're going to show you how we started from just the vanilla application without any caching optimizations. And we're going to show you progressively how we optimized it for the browser, for CDN, and also installing a reverse proxy. So we'll go through that step by step and kind of show you all the optimizations we talked about in the first half, but in a real world scenario. We're also going to demonstrate the few minor modifications we've done to the web page test instance. And so please run that test if you didn't get a chance on that custom instance on wpt.advancedcaching.org. And after the break, you'll see we'll go through some of those additional diagnostics that's going to help you further understand what's the best caching strategy. Right? Mm-hmm. We're going to conclude with some real-world scenarios, bring it all together with an e-commerce scenario, a high-peak traffic scenario, and a mobile native app scenario, and then conclude with Q&A. So thanks, you guys have been great. Please do continue to ask questions, and see you after the break.